Same slope as the solution curve through that point. So when we were doing differential equations, you might see something like y prime equals like x squared plus y squared plus xy plus 2 or something weird like that. So the notation that we're going to see here when you're working on slope fields is you're going to see that the derivative equals the function evaluated at the point xy. And the reason they're going to write it that way is because when you are drawing a slope field, for you to be able to figure out what your little line segment should look like, you're going to plug the point into the function, and whatever you get as a number for that point plugged into the function is the derivative at that specific point. And then you're going to draw a little line segment that has a slope like that. So if your line segment had, if you plugged in a point and you got that y prime was 1/2, you're probably going to have a little segment that's kind of horizontal, like a little bit slanted, but not very slanted. If it equals 15, then you're going to have a line segment that's almost perfectly straight up and down, because that's a really, really steep slope. So that's when you're looking at these, you can see, like in this first one, that these ones have a slope of 0 when the x-coordinate is 0. You guys see that? When the x-coordinate is 0, they have a slope of 0. Over here, you can see that when the x-coordinates are positive, the slopes are positive. Over here, when the x-coordinates are negative, the slopes are negative. Does that make sense? And then I can see when the x values are smaller, the slope is a little bit less steep. When the x value is bigger, it's more steep. So I can kind of see how the numbers are being plugged in there. Does that make sense? Okay. All right, so the slope field gives you the general shape of all solutions of a differential equation. So the general shape of all solutions to a differential equation. So it's the graphical equivalent of putting plus c at the end, because we're getting all of them there. And the reason that we look at the graphical approach is because some of these equations would be really hard for us to solve. If you guys remember when we were doing the worksheet before Christmas break, we were matching differential equations with their solutions, and that was hard enough to just match them, much less like come up with the equation on your own. That would be really difficult. Okay, so we're going to do this because graphical approach is easier. You getting all your notes written down? No, I'm not. It hurts my heart, Pat. It hurts my heart. Yeah. I don't believe, if you truly loved me, you'd be taking notes right now. Well then. All right, here's there's so many things I could say. So many. All right, so for this we're going to go ahead and sketch the slope field. Sketch the slope field for y prime equals x minus y. And if you think about it, a slope field could be something very large, right? Because look at on here, these slope fields are only from -2 to 2, right? And there's a lot of little lines on there. And for every single little line, you have to plug in that point to see which way you should make that line slant. Yeah.
Would we ever have to actually draw these?
Yes. So we're gonna look at first before we start drawing them. We're gonna see when you look at the equation, because there's some things you can pick up on the equation and make like rather easily. There's some things you're gonna notice and be like, oh yeah, I can draw a bunch of lines real quick there. And then there's other parts you're going to have to think through more. So today we're going to focus more on matching, like matching them up so you can start to see where the patterns are, and then they'll be easier to draw. But when we look at this, it's going to be important if they ever ask you to draw a slope field that you know how big they want the slope field to be so you don't waste your time. So on this one, they only want us to draw the slope field for 3 different points: the point -1, +1, the point 0, 1, and the point 1, 1. So we're just going to draw it for those 3 points.
Intervals instead sometimes?
Yeah, and the tricky part about intervals is you don't know how far apart you should make things. Like, should you do every 1 or every half or whatever? Yeah.
That's at your discretion, or
Pretty much at your discretion. They might specify. I'd say at your discretion unless they specify.
okay.
Yeah. All right. So I'm going to say this is 1, 1, -1, -1. So I'm going to go ahead and make a table. So we have the point -1, 1, and the point 0, 1, and the point 1, 1. So for the first one, yeah, if we do -1 minus 1, we get -2. If we do 0 minus 1, -1. And if we do 1 minus 1, we get 0. Okay. So that means at the point -1, +1, we have to draw a little line segment that has a slant that would make it look like a slope of -2. So pretty steep, yeah. So it's a line going down that's pretty steep. At the point 0, 1, we have to draw a line segment that looks like it has a slope of -1. So is it going to be more steep or less steep? Less steep. So at the point 0, 1, slope of -1. And then at the point 1, 1, we have a slope of 0. Yeah, flat. That's perfectly horizontal.
So you can see the changes.
All right, this is the point where we're going to go ahead and take this little piece of paper, we're going to stick it on our notes. So I'll come around and give you some tape.
No.
Okay, so the instructions for this are going to be to match the slope field. How's the struggle? Match the slope field with its differential equation.
Wait, that's already on the thing.
Oh,
Down the paper, yeah.
sorry. No one's more disappointed than I am. Did you see me struggle bus writing on that tape? For nothing.
Just leave it.
For nothing. Okay. So the slope fields are a little bit easier to match if they're in terms of one variable and not two. So we're going to focus first on the second one and the third one because those are going to be a little bit easier to determine. So if we think about this, we're thinking about different points that we could plug in and what kind of slopes they're going to have. So these slopes are going to be completely based off of the x values that I'm plugging in. The y value of the point does not matter. So when I plug in an x value of 0, what's my slope going to look like?
0.
0, right? Is that horizontal or vertical? Horizontal. So everywhere I have an x coordinate of 0, I'm going to have a horizontal line. So which of the three does that look like? Yeah, I definitely see A has horizontal lines. This one has some horizontal, like this one looks like it's probably horizontal, but these are not, right? So this one definitely does not go with B because when the x value is 0, it should have horizontal lines. Does this one have horizontal lines? No. Okay. So it's probably A. Let me look at my notes. Yeah, it's definitely A. The other thing we can consider is what if you plug in an x value of 1 versus an x value of 2 versus an x value of 3? What are you going to notice about your slope field? It's going to get steeper. Do you guys see that happening with A? So it's less steep and then it gets steeper, and you'll notice that these are all positive slopes, right? You're plugging in a positive one, it's a positive slope, positive slope, positive slope. What happens on the other side of the line? negative slopes, but they're about the same level of steepness. So the further away you get, the more steep they get. So you guys see how we can kind of look at the slope field and kind of picture what it has? Does that make sense? Okay. Now you'll notice that since there's no effect, the y-coordinate of the point has no effect, you're going to notice that all these vertical lines, like the columns of the slope field, are identical. So this entire column has perfectly horizontal lines. This entire column has all slopes of 1, and you can tell that they're the same. You guys see that? Okay. So we're going to say that this one is number 2. Okay. What are you going to expect to see for number 3?
Same things that sideways.
Yeah, it's similar but sideways, right? So instead of all the columns being the same, all of the rows are going to be the same. So when the y value is 0, we're going to have all horizontal slopes. When the y value is 1, we're going to have a slanted slope that's positive. When the y value is 2, we're going to see a more steep but positively slanted slope. So which one does this one go with? So yeah, it goes with C. Yeah. So this one you might notice that because x is positive on the right and negative on the left, we had positive slopes on the right and negative slopes on the left. When we were looking at the y's, we had negative slopes underneath and positive slopes above because that's how y's work. Yeah.
So, but why is there nothing at x equals? Why?
So at y, it's there would be horizontal lines here, you just can't see them because they're on top of the axis.
But why are they horizontal?
They're horizontal because the y-coordinate there is 0. And a slope of 0 is a horizontal line.
The only reason I'm thinking this is because... Oh, never mind. Appreciate it.
Yep. All right. And then if we look at the other one, so think this one through. What would you expect to see on a graph that looks like this? Yeah, 1. So at the point 1, 1, you're going to see a slope of 2, and I can kind of see that, right? I got a slanted slope. What happens here when we have bigger positive numbers for x's and big positive numbers for y? Yeah, we're getting steeper slopes. So I'm noticing with this one that in the first quadrant, I'm adding a positive number with a positive number. So all my slopes are positive up here. And I notice that they are less steep the closer I am to 0 and more steep the further I am from 0 on both of those. You guys see that? And then in the third quadrant, why am I seeing all negative slopes in the third quadrant? If you think about your points, x plus y. Why are all my points, all the slopes in the third quadrant are all negative? Why? The x and the y is going to be negative. So if you're adding x and y together to get the slope, then it would make sense that all those are negative. And then how come we're finding that it switches back and forth between positive and negative in quadrants 2 and 4? Yeah, they're always alternating signs, so it would depend which one's bigger. Yeah. So these points are negative because they went to the left more. The left number is bigger than the y number. So it's more negative than it is positive, and that's why those slants there are negative slopes. Does that make sense? Okay. And then if you guys can see, do you guys notice this part right here? What are we seeing right here? Those are slopes of 0. Why would you see a slope of 0 along that line? Yeah, they're canceling out, right? Negative 2 and positive 2, negative 3 and positive 3. The x's and the y's are opposite signs, so they're all canceling out. Okay. So do you see how we can kind of think through what we're doing to be able to recognize what slope field goes with which equation? Okay, so that goes with...
Right?
Yeah. Well, we only get to a certain level of difficulty, you know. All right, here's the next one. We're going to sketch the slope field. For y prime equals 2x plus y. And then we're going to use the slope field to sketch the solution for, sketch the solution that passes through 0 or 1, 1. Solution that passes through All right. So if we start looking at some of these, if we have the point here at -2, 0, what would the slope be at -2, 0? -4. So I'm getting the point because I'm just looking at a point on the graph. -2, 0 is a point on the graph. And then I'm plugging it in here to get the slope. So 2 times -2 is -4 plus 0.
Oh.
It's -4. So that's a pretty steep negative slope, right? So make it pretty steep. Here's -4. How about if I do the point -1, 0? -2. It's a slope of -2, so we're definitely less steep. How about if I do the point 0, 0? It's a slope of 0. How about the point 1, 0? Slope of 2. How about the point 2, 0? Slope of 4. Okay, so there's one row in our slope field. Yeah. What if we do the point -2, +1? -3, yeah. So that's going to be not quite as, it's more steep than this one, but less steep than that one, right? No, that was not a good level of steepness. Okay. How about the point -1, +1? -1, +1. What would that be? -1? How about 0, 1? Would be 1. How about the point 1, 1? 3. How about the point 2, 1? 5. Mm-hmm. Now, I know that I'm going to be trying to sketch the graph around the point 1, 1, so I know that my slope field is going to need, I'm going to need to have some more points right in here. Does that make sense? So I'm going to go ahead and do the point 1, 2, just to see what happens right there. So what should we get at the point 1, 2? 4. How about at the point 2, 2? 2, 2 would be 6, right? How about down here at the point 0, -1? Would just be -1.
3 now.
Okay, so if we draw this point right here, there's the point 1, 1, and we sketch the line, and what we're doing is we're sketching a curve that follows this slope and kind of follows the pattern of the picture. So if we know that the curve goes through this, because it goes through this line, I might want to see what happens like right in here, so I can know, like I can see that up here my curve is probably going to go like that. Yeah. You guys see how that kind of follows the slopes up there? Down here I know that at some point it's going to flatten out, but I don't know exactly where it should go because my slopes are pretty far apart right now. Does that make sense? So I might want to plug in like 1/2, 1/2 and see what it looks like there. Does that make sense? And maybe plug in like 0, negative 1/2, and kind of see what happens down there to give me an idea of where my slope should go. So I'm going to try 1/2, 1/2. What happens when I plug in 1/2, 1/2? 1.5 or 3 halves, right? 1.5. Okay, so that is like that. How about the point 0, negative 1/2? Negative half. Do you guys see how there's a point where you could probably do some of this in your head? You don't necessarily need to write it all down. I think it kind of depends on how your brain works. Okay. So if we follow this down, I'm going to guess that it goes somewhere in here. Goes back up. So what I would expect if I could write the equation of this curve is that if I was able to go back and integrate this, and I can't integrate it, I don't know how because it has an x and a y in it. We didn't do those, right? But if I was to do that and was to write the equation with a plus c on the end, I'm going to expect my plus c to be somewhere around here and for the curve to kind of match up with my red line. Does that make sense?
Yeah.
So this represents lots and lots of different answers, and all those different answers are on this picture right here, and this is just one specific one that goes through that point. And I would expect that if I could integrate that and write the equation for it, I would find a c value somewhere in here, and I would have a curve that matches that red line. It would make sense. Okay. So, if you guys look at this, what they did is they drew a specific picture of a solution for this. So this is a slope field that represents the differential equation x minus 2. And this is one specific solution that would have worked for it. So you could have this. If you started at a different point, you might have a slope field that's down here, or you might have an equation down here that fits that same differential equation. You guys see that?
Yeah.
Right, so that'd be like, you wouldn't have a plus 1 on the end, it'd be a little bit different because your c is different.
What about the rest of it?
You could have, if you were here, you could start with this one, and then you'd be looking at this curve right there. Does that make sense? And they're just following it out, so out here they're just getting real steep-like. Does that make sense? So we have lots of different solutions here. That's what the plus c means on the end. Okay, so when we are matching up, are you guys listening? When we are matching up our differential equation with the slope field, we are not necessarily considering what the solutions are. We're just thinking about what points would I plug in and what slopes would those points give me if I did plug them in. So if you look at this first one, is the y-coordinate going to change what my slope is at all? No, the entire slope is based only on the x-coordinate. So what does that mean I'm going to see in my slope field if the y-coordinate does not matter? Yeah, your columns are going to be the same. So whatever you got when you plugged 0 in for x, that's going to be the same up and down for all the points where there's a 0 coordinate for x. Wherever you have a 1 for x, they're going to be the same up and down for all the 1s. So can you guys tell which letters have the vertical columns, right? Like columns that are all identical, because that's going to help us narrow down. So F is one of them. What's another one? E, I, and D. Okay, so these, the first one, since the y-coordinate does not affect the numbers at all, that means that these 4 are the only options that would work for number 1. Does that make sense? The only options that would work for number 1. Okay. So what are we going to expect as our x value gets bigger and bigger and bigger? Slopes are going to get steeper, 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 right? So if we look at this, are we seeing that the slopes get steeper on all 4 of these? No, we can narrow it down a little bit, right? And as the x gets, if we move the x towards the right, we're going to have steeper positive slopes. So if you look at these, which letter could you automatically say is not one of them? I can say that E is not one, right? Because those slopes are not getting steeper. So number 1 is definitely not E. Why is it not F?
Is that an erasable pen?
It is. Yeah. Thank you. Thank you. Why is F not an answer? Yeah, it goes positive and negative. That doesn't make sense if we're only plugging positive values in. Okay? All right. The other two are kind of similar. So maybe we should consider something else. What else? What else could we consider that could help us narrow it down between these two to figure out which one it is? Yeah, what should happen, or can you guys tell where there would be a slope of 0? At -1, right? If you plug -1 in, that would zero this out. So which one looks to have a slope of 0 at -1? They kind of both do it, right? They kind of both have a slope of 0 at -1. I can see it on this one. I can see it right here, right? It's got a positive slope to the right and a negative slope to the left, so it must have a slope of 0 in between. I can see that over here as well. What would we expect to see on the left side when you start to plug in negative x values? What are you expecting to see? Negative slopes, right? So if we are expecting that when we plug in negative numbers that are more negative than -1, we're going to start to see negative slopes. Do we see that on D or do we see that on I? You see that on I. On D, if you look, right after you have that horizontal slope, you've got some positive slopes, and that does not make sense. Yeah. So number 1 has to go with I. Did you guys see how we kind of thought through that? We were picturing what we could plug in. Okay. What are you guys going to see? So if we look at this one, we've got x squared. Again, we do not have a y value. Our y value does not, when it gets plugged in, it doesn't make a difference, right? Because it's not being plugged in anywhere. So the y value makes no difference. What does that mean for us? What does it mean if the y coordinate doesn't affect the slope at all? The columns are the same. All the columns are the same. So that means that for number 2, we just said we used I. So again, that means that our options are D, E, and F. If this is x squared, what happens no matter what x value you plug in? Positive. So we're looking at one that only has positive slopes. Yeah, so F is out. And wait, is E out? Oh, it has some zeros. So it would have to be D. Does D make sense?
Yeah.
Yes.
Yeah, so if you have the numbers that are smaller x values have less steep slopes, and then as the x gets bigger, the slope gets way steeper and it looks like a vertical slope as you get towards the edge. That makes sense because the x value would grow so quickly, right? If you go, it would not have a negative slope because a negative number squared is still positive. Yeah, so if we think about, we've got a 0 slope where x is 0, right? Okay, so go ahead and work on that.